Good evening, all. I hope you guys can hear me.
Yes, sir, we can hear you.
Great. So I hope you guys are all doing good. Everyone, so let me see the
Yes.
participants. Hello, Akansha. Hello, Abdul. Hello, Abhishek. Hi, Amreen. Hi, Deepak. Hi,
Hello,
JP.
sir. Good evening.
Good evening.
Hi,
Good evening.
sir.
Hello. Hi, Kanchan. Hi, Kripa. Hi, Lisa. Hi, Madhvi. Hi, Raj. Hello, Sonia. Hi, Ujjani. So I hope you guys all are doing good. So we'll not waste further of our time, right? So since it's a 1 hour session, let's really get started. So I guess you are already aware of the agenda for this session, which is basically EDA, which is a very important topic in data science world, right? And within this topic we will be basically trying to use Python, but from a non-coder perspective, right? So that's what the idea of the entire session for today is. That's basically doing EDA analysis and doing a lot of insights, a lot of visualizations, but having using less of codes, right? So before I really start with this with this webinar, I just also wanted to understand from you guys what is the first word that comes to your mind when we say EDA. What do you think? What's the first word, and that's applicable to all?
Electronic.
Electronic. Okay, E stands for electronic. Okay, what else?
Exploratory.
Exploratory. Yeah. Okay, so we have E for electronic, E for exploratory. What else? Data analysis, exploratory data analysis, right? Yeah. So if I say about exploratory data analysis, what does comes to our minds? It's definitely not electronic. It's from the perspective of data science. It's all exploratory data analysis. But what's your take on EDA? Statistical summary, right? Yeah. What else? I want you guys to participate in this. Yeah. So and it can be any thoughts which you feel like, okay, this can be as a part of EDA. Statistical summary, mean, median, mode, outliers. Okay, so we have all of that coming from Kripa. So yeah, uh, I guess you are all aware of about the basic premises of data science, right? So in the context of data science, one of the most important task in a life cycle, in a project life cycle, is EDA. Okay, and that's applicable for any projects, applicable for any client engagements, applicable for even situations where we are deploying models in the cloud, right? So everywhere this kind of a task is applicable. Okay, so EDA is a very important task. Okay, now unlike the other modules of data science. So let's say if you have linear regression or logistic regression, or let's say neural networks, or let's say gradient boosting, right? Different modules of data science. There is no such an hard and fast rule about what EDA is. Okay, so that's what we will try to explore today. That what do we mean when we really say EDA? Okay, and how as a modeler you can influence EDA, right? In terms of basically guiding your data science project to a success, right? And also to ensure that you are actually driving insights. Okay. Now I've seen a lot of people who are really focused on the coding part. For example, in terms of having doing a lot of research on a particular algo, but not paying an equal attention on the insight part of it, right? Or on the business value part of it. But I would want to take this session as an opportunity to tell you guys that it's very important Okay, at the end of the day, any analytics or data science work that we are doing, it's entirely for the business, and that business has to drive value from it, right? So even if you, let's say you are running a very complicated deep learning neural network, and you get a very high accuracy out of it, but if it does not plays any role in terms of, value addition to the business or insights generation to the business, it's just a model which is running on a computer, right? So that's it. So from a data science perspective, EDA plays a very important role in terms of storytelling, right? And yes, it includes a lot of generally it includes a lot of statistical summaries and outliers or missing values, right? But the most important premise, guys, and consider it as a takeaway, is how do you tell a story from an EDA, right? So that's the first thing that you should know about what EDA is or what we try to achieve from it, right? So during this session, what we will do, as the session title suggests, that we will be definitely doing EDA analysis, but we will try to do the EDA analysis with minimum line of codes. And when I say minimum line of codes, it can be just be one line of codes, right? So I'm not sure, like from your perspective, like how much Python, but I assume you guys have an basic understanding of what Python is. So anyone here who does not have an a clear understanding of a Python environment, I hope everyone here is aware of Python. So this is basically a Jupyter notebook, which I have used for using this scenario for this. Everyone have used only Jupyter notebook. Okay. About others, everyone comfortable with basic Python? Everyone, I hope. Basic Python. Okay. So and hence what I will do is, like, I will show you the one liner codes, right? So that's I think will give you the power of using Python in this case. Okay. So this is basically in so Jupyter itself, for people who do not who are seeing this interface as for the first time. Jupyter is basically and IDE, where you write codes, or you write Python programming codes. Okay. And Jupyter is very good whenever you want to showcase your work. So for example, I am using Jupyter to show you the work, right? So generally when we do programming, we know language tools like C++, even R Studio, right? We know that it's a more of a programming based tool. It's not very good in terms of a user consumption. But in this case, the Jupyter environment that you're seeing, it's pretty good in terms of displaying the things, also in terms of visualizations and charts, which you will see as I go on in terms of presenting it. So it becomes a very good a platform to showcase things. Okay. The same codes can work on different IDs, which is like Spider or PyCharm for Python. But as I said, Jupyter is a very good, comfortable space where you can really have a lot of visualizations, in fact. Okay. So no worries. I will be sending this notebook to you guys, so that you can, or that this will be maybe posted with the link of this video. So you guys will have an access to this notebook, and you can play with it. Okay. Neural networks run on Jupyter? Yes, definitely, Kripa. It can run on Jupyter itself. As I said, Jupyter is just an IDE. The fact that we are writing only Python codes in a Jupyter or a PyCharm or an neural or an, let's say, Spider environment, uh, it's irrespective of the fact we can run anywhere. So yes, the answer to your question is yes. Okay. Use Spider only, that's completely fine. Tanuka, I'm sure that you will see when you see the codes, if you have used Python, so they are exactly the same. Okay. So again, coming to this session, so we will be doing ED analysis, Pandas, using Pandas. So Pandas is basically an library So library is basically a module that we have in Python, and it tries to do a lot of things. So it's imagine it as an umbrella object, where in which it includes a lot of modules, a lot of functions for data processing, right? Because in Python, we generally have a lot of data handling stuff, as well as machine learning, and that goes hand in hand with any kind of data science work, right? So that's what we will doing. But the most important, I would say, the focus of the session would be on interactive visualization, and I will tell you what interactive visualization is, and kind of very kind of automated ED analysis. So for example, let's say if I do not want to write long chunks of codes and get insights or have visualizations, then what is the alternative? And that's what I will show you today. Okay, because I'm not sure how many of you guys are aware of it. So Python by default, or Jupyter by default, is not an visualization tool. Okay, any visualization tools you guys can uh, say, like, if you have used, if you are aware of any visualization tools which you feel like, which are there in which you have used or which you are aware of. Tableau, yeah, Tableau is a very good visualization tool. Power BI, yes, definitely. Power BI is also good. So when I say a visualization, it means it's very good in terms of interactive, right? So you can uh, that's fine. But when I see these kind of tools, you can click upon it and see the variables, see the various graphs and all of that, right? So by default, tools like Tableau and Power BI has been made for visualization or for BI consumption, right? On the other hand, Python is not. Python is more based on programming, but that's what, again, I'm repeating. But that's what the focus of this session would be, to have those visualizations, but using one single line of codes, right? So that's what you guys will know today. Okay. Again, coming back to EDA, so yeah, that's what the the overall objective is, to basically the data that we get in any kind of work, be it in your, let's say, interview projects, or be it your case studies, or be it in the industry, the data is always messy, the data is always unclean, right? The role of any data scientist is to use combine and transform and aggregate the different data sources, make it at one, so that we can consume it for the future purposes. And that future purpose is basically modeling, right? So we basically go from untidy data to a clean sorted data. And when we have things arranged, obviously we make a lot of sense in terms of understanding it. Okay, why this is important, guys? Why the visualization, or why the storytelling is important from an EDA perspective also? Because of the fact that at the end of the day, as I said, it's generally the business who are consuming, right? So for example, let's for a minute put yourself into the shoes of, let's say, CEO of a company. And obviously you will not be always interested to see long chunks of codes and a lot of hyper parameter tuning, all of that, right? You will be more interested in terms of a story which the data can is about to tell, right? So that's basically always the objective. And within in all of this, obviously there is a lot of things which go back and forth in terms of model building, in terms of data processing and data handling, and subsequently EDA, right? So EDA, as I again said, is like the first step in any kind of data science project. So to give you a formal definition, it's a process of visualizing and analyzing data to extract insights from it, right? So this is very important, guys. Insights from it is what we mean is that data has to tell some story. Okay, so I'm sure all of you guys are interested in data science, and that's the reason why you guys are here. So as you see, as it says, like data and science, right? You have to tell a story about the data. When I say that, a very simple example of that would be, let's say I'm saying the average the age of people living in let's say Los Angeles is let's say 31, right? And this is just a fact, this is just information, right? What is an insight from it? So that's what EDA's true definition is. Okay, so if you do not provide any insights, if it's a plain reporting, it does not serve the the best purpose of it. So obviously always focus on deriving the insights, and this is something which no tool can do. Okay, not Python, not Tableau, not ClickView, not the best of the best tools that is there and available in the industry. There's something which you guys can do, and that's where you guys get hired, and that's where you guys are get paid for doing that stuff, right? So again, EDA is a process of visualizing and analyzing the data. In other words, it's a process of summarizing important characteristics of data in order to gain better understanding of the data set, right? Important characteristics. So what exactly my data is saying, right? So that's what EDA does. And why do we need it? I think I've talked a lot about it, but just to give you pointers about it, obviously to give insights about the data, understanding the underlying structure. What we may mean by the underlying structure? So underlying structure would be something, let's say, when you have multiple columns, right? So imagine you have got, let's say, a lot of columns and a lot of observations. So what is the underlying structure of your data? Do you have got many categorical variables, or do you have got numerical variables, or do you have a lot of missing values? What is the structure of the data, right? So that is also one of the important reasons why we do EDA. Extract important parameters and relationships. So this is very important, guys, that once we do understand the structure of the data insights, we also want to analyze the relationships. So generally, from a machine learning point of view, we know that there is a concept of a target variable, a variable of interest, right, which is which we call as a dependent. So we try to understand the relationship between dependent and independent, and a lot of independent variables, right? So this is where again EDA helps us to form a ground and underlying assumptions. So again, data science as a work is based on a lot of assumptions, a lot of hypothesis testing. So we try to test those assumptions statistically backed by the data through ADA. Okay, so that's all basically. It's in terms of why do we need of an EDA analysis. And as I said, it is very important in terms of insights generation and storytelling, right? So if you do a proper EDA before actually deep diving into, let's say, model building and a model training, right? It gives you a lot of groundwork in terms of what the data is telling, what kind of story, what kind of insights you can find out, right? So do you guys get the entire the framework of an EDA? Okay, so if someone says EDA, you just don't talk about statistical summaries or mean median mode. You need to talk about insights, you need to talk about storytelling, and you need to talk about uh, uh, you know facets of the data, right? Characteristics of the data, attributes of the data, which can basically serve a purpose to the client, to the business, right? So that's is the framework that you should guys always adopt in any kind of ED analysis. And as I said, insights is something which cannot be influenced by a Tableau or a Power BI or a SQL or a Python or a R, right? So this is something which is very unique to you. And if you develop that mindset in terms of interpreting the relationships, understanding how the charts look like, and what it is actually telling, it becomes a super solid journey for you guys to grow in the field of data science. Okay. I hope I made sense. Before I really now what Python will help here is that we'll try, as I said, very single line of codes, and we will try to have an interactive way of. So we'll not go the standard ways of Python of writing long chunks of code of doing correlations and finding statistics and all of that. We will be using some very beautiful packages that have come quite lately, and I got some time to explore that, and I thought it would be a great way to introduce this to you guys so that you guys can obviously explore and use it for your own work, right? So, but before I deep dive on that, any questions, guys, on EDA or anything else which you wanna ask? I hope till here you guys are with me. Any questions? Again, I want you guys to speak up and yeah. Yeah, Tanuka. On what? Can you give an example on what? On an EDA? What libraries on EDA? Okay. So I will be the example I will be share using a data set right now, Tanuka, and I will be showing you how to do the analysis. Okay. So I will be doing it. ED example using Panda. So that's the next plan. Okay, Abdul. So that's what we will do right now. Okay. We will be using 3-4 libraries actually for doing it. And as I said, we will be using some special libraries that we have in Python, which is very good and it makes your life easy. Okay, from an coding perspective. Okay, what libraries are prerequisite for this? Okay, so let's start from that part. So definitely we will be using Pandas. Okay, so Pandas is one. Second would be data prep. Okay, so this is something. So there are two kind of libraries which are generally there for Python. One is something which is there by default. So imagine, let's say you buy a car, and there are certain features which are there by default, right? But there are certain features which you get as an add-on, which you want to customize, right? As you want it. Okay. So similarly, so there are certain libraries in Python which is there by default, like Pandas, NumPy, scikit-learn, and so on and so forth. But there are certain other libraries which are custom, which you use for certain specific purposes. So the libraries which we will be using is definitely data prep. So this is definitely the first custom library that we will be using. Okay, so you guys want to download it. Okay, so to download it, follow the simple command of pip install uh, data prep. Okay, so by this command you will be able to install this particular library. Okay, and the another package we will be using is profiling, Pandas profiling. So there's another add-on to Pandas which allows you to develop interactive charts based on EDA. Okay, so that's the, I would say, the second custom library that we will be using for this. And the third is AutoViz. Okay, so this is the part of Sweetviz. Okay, library, and that's the second library which we will be using. So for this, for doing this, do pandas underscore profiling for installing it. Since again these libraries are as I said, it's part of custom library, so you guys need to download it uh, separately. Okay, so you can do an pip install either in Jupyter or in kind of a conda environment, and download these libraries. Okay, and warnings are just to for me, so there are certain warnings which gets displayed. So just from an the sanity of this notebook perspective, I have chosen to ignore all the warnings, right? So it basically ignores the warnings. I am using an data set, and let's try to talk about this data set a bit. So it's basically about parking violations, right? So so what we have is we have got a lot of features. Okay, so let's try to see how many features do we have. Okay, so let's try to check the shape of it. Close these guys. Shape. Yeah. So let's see the shape of this entire data set. I'm using a small data set in here. So it's around 201 observations and 13 variables. The actual data set is quite big. I have extracted a small amount just to ensure that we are able to show you the summaries within the time limit, right? So otherwise, it's the data itself, it's quite huge, and I'm using a subset of it. So what this data is all about, it's about parking violations. And we have variables like ticket number, date, time, state, division, location. So violation description, fine issuing agency, latitude, longitude, GPS, and zip code, right? So we want to see the columns of this data set. So we can obviously use the command dot columns, right? And we know that these are my different columns that I have in my data set, right? So 13 columns and 201 rows. Yeah. So we'll try to see if we can have some kind of insights from this. Again, not using a lot of codes. Okay. So, but before I show you the how do you check the tail of this? So you can, instead of head, Kripa, you can use tail. Okay. By default, you will be able to see the last 5 rows. Okay. Let's say you want to see the last 10 rows, not last 5 rows. What you can provide is 10 here. Okay. So this, in that case, will give you the last 10 rows. Okay. So that, so check the tail of the data. Simply, it's simple enough, df dot tail. And to check the head of the data, it's again simple enough, df dot head. With me till here, guys, in terms of what the data is about, it's simple number of data available at a ticket ID level at every date, and we have information about the location, the description of the violation, fine, what kind of agency which has issued it, and kind of locational aspects, right? So that's what in terms of information that we have. Okay, now let's try to do some kind of summaries into it. Okay, now first I will show you the basic version of some of the EDA features in Python, and then I will go to the the advanced version. Okay, so to show you the basic version, so let's me actually not do this and show you the default one. The default one is df.describe. Okay, so describe is one of the important uh, summary features in Python, which allows you to give you the the statistical summaries of all kind of numerical columns. Okay, so if you see ticket number, plate ID, division, fine, latitude, longitude, zip code, so it gives you the the statistical summaries. But do you consider this and this as an important variable? No, right? So I am not concerned. So even if ticket ID is a numerical column, it does not make sense to find the mean or the standard deviation of it. It's just an ID column, right? So I can fairly ignore it, right? What can be an important column for to check is fine, right? So we have got 201, we have got mean as 46, right? Standard deviation is 46, minimum is 26, first quartile is 25, 50th quartile is 36, and 75, third quartile is 41. The maximum is 301, right? So we see a quite a difference between my minimum, which is 26, and maximum, which is 301. Hence you also see a quite a good standard deviation, right? So what do we so in terms of, again, from an inference perspective, what can we say, right? So we can definitely say, since our mean and our median, right? So mean, which is 46, and median, which is around 36, they're not exactly same. And then we can see that obviously there is a presence of certain outliers. And what do you feel, where are my outliers? Do it is on the the minimum side of it or on the maximum side of it? What do you feel? Do you feel the outliers on the minimum side of this distribution? Just looking at this data set, this summary. So this means it's towards more towards the maximum side, right? So since we have a maximum of 301, and if you see my first quartile is 26, minimum is also 26, right? We do not see a lot of deviation here. But if you see
75th percentile is 41, and the maximum value is 301. So the outliers is between them, I think.
exactly, Tanuka. That's completely right. That's completely right. So we have a lot of outliers which are positioned towards the maximum side, and we will see this when we have the reports. Okay, Nivedita, you wanna say something? You have raised your hand. Let me know if you wanna ask something. Okay, Okay, so that's that. But as I said, what we are more interested for today's session is to have, some kind of visual summary. This is something which we all know. This is something which is fine. But can we have something? Can we have something, where we can have all kind of these interactions, which means I can check the relationships also. I can have the insights also. I don't need to do it by myself. I can have Python doing that. Okay, so let's try to get into that zone. Okay, so we can also find the number of missing values. So we know that, okay, division has got 201 missing values, and zip code has got 32, followed by GPS, longitude, latitude. These guys have also got six missing values, right? So the which variable has got the maximum missing values? Okay, division. Okay, now now let's try to come to the main focus of this session, right? So as I said, it's about non-coding. So I can continue doing all of this, right? I can continue finding the summary statistics for the variables. I can continue finding the missing values, the outliers. I need to write separate codes to find the correlations or see, visualizations between my variables, right? So I have to do a lot of coding. Okay, but what if I don't want to do a lot of coding? What if I just have just one line of code and it gives me most of the things that I want? It's a report, right? It's a report, and which I can use, and I can basically derive insights from it. Okay, so in here comes the picture of the first package which I referred, which is basically data prep. So within data prep, there is this beautiful function called create report. Okay, and this can basically use all of your data. It's pretty simple if you guys see in terms of the coding. So what is the argument it is taking? Df. What is df, guys? What is df? Simply, it's my data frame,
Data frame.
right? So data frame which I
Data frame.
read, that's what my df. So it's as simple as that, as just like one line of code. Okay, so now let's try to run it. Okay, it might take some time because it will try to do a lot of things. Okay, it will try to do a lot of analysis at the back end and generate a very beautiful report. Okay, so let's uh, give it some time. Okay, so this where it will try to see, it will try to give us an inference, or generate a lot of insights based on each of the variables. Okay, and let it pop up, and we will be seeing that how this report can be so handy, instead of writing separate codes for separate variables and doing a lot of visualization for separate variables, right? So like in Python, you have a particular package called matplotlib to do a lot of visualizations, because as I said, uh, generally what we use for visualization is Tableau, right? So Tableau and uh, Tableau and uh, Power BI, which are like the tools that we use. Okay, so for that, for that, we need to basically shift this data to a Tableau. But here we are using Python, which is again a free source, as well as it can be used for machine learning purposes. So basically, you have just one repository to do everything. Okay. Okay, so enough of the talking. Let's now see actually how the report is. Okay, so if you see, this is what my report looks like. Okay, so I've got this is the report. We have got overview, I've got variables, we have got interactions, we have got correlations, we have got missing values. Wow, this is like one single thing to do every kind of work that we, every kind of angle that we want to see. Okay, so it gives you a very good picture, like what is the statistics of my data set. We have got 13 variables, 201 rows. It gives me the number of missing cells, which is 251, the percentage, which is 9.6. Okay, so number of missing values, total number of missing values is 251. Okay, and it's like just the one unique values. Okay, just don't consider it as one unique row. Obviously there are 201 rows. It cannot, like entire row is missing, like one individual value which is missing, which is 251, 10%. Okay, so 10% is missing, and duplicated rows. That's something which we want to always see, right? From a data sanity perspective, and this does it by itself. You don't need to check by running some kind of writing some kind of complex algos to see like, oh, how many duplicate rows are there. It will tell you if there are any duplicate rows or not. Okay, then there's the memory and all of that. It also gives you an idea of what are the kind of variables. Numerical is 5, categorical is 7, geography is 1. So we have got information about longitudinal and longitudinal. So they come in there, right? Then we have on the right, we have the insights. So we have division has 201, 100% missing values. Okay, so in here when we saw, right, so we saw division. Okay, so 201 missing values. But don't you find this as more interesting? Like from an information perspective, it's that it tells you 100% is missing, right? Instead of just the number 201, we know even the percentage, like that. Okay, when the entire column is missing, okay, latitudinal has 3%, longitudinal has 3%, so on and so forth. Okay, this is very important. Itself it tries to find if something is skewed. Okay, plate id right now, again from an consumption point of view, it might not be very important, but it sees that it is skewed, right? Which means that let's say if you actually run this report on any other data, and where you have not just the id columns, you have the other columns as well, it can tell you which is skewed, which is not. Okay, and skewed, we know the skewness basically tells if there is an inclination towards either the mean or towards the mode, right? Positive skewness or negative skewness. So that's basically something which it tells by itself. You don't need to find out for the variables, right? It will automatically tell that which variables are skewed, and if it is not mentioning, obviously those are not, right? High cardinality, so we have got obviously distinct values, so which means there is a high cardinality, 174 distinct values, right? Location. So state has constant, length, division has all distinct values. Obviously, it's everything is missing. Lon has 97% has negative values, right? So this particular report, rather overview itself, it can tell you what are the data basically standouts, again, without you doing any kind of data sanity. So this is something which is which we spend a lot of time, I will tell you, uh, guys, when we actually do kind of any kind of analysis, we spend a lot of time in finding what are missing values, which is skewed, which is not, and so on and so forth. Okay, what is the impact of a column being skewed? Okay, so it's all about the data distribution. Okay, to give you an example, let's say let's try to talk about the price of the average price, okay, of, let's say, houses in Gurgaon. Okay, let's say the average price of a flat in Gurgaon is, let's say, 1 crore. Okay, uh, but when you actually try to go and see a lot of lot of, and you see the what is the actual price point, you see that there is a lot of data. There is a lot of presence of values which is more than 1 CR. Okay, there's a lot of presence of values of houses which is more than 1 CR. Okay, so even if the mean is 1 CR, we see there is actually a lot of presence of houses whose prices are greater than 1 CR. Okay, so in this case my column is skewed. Okay, so so what is the impact of this column per se? Then obviously my reliance on my mean, right, uh, reduces. Okay, so let's say if if I go with the value that, okay, 1 CR is the the average price of a flat in a Gurgaon, that reliance of that value reduces. Okay, because I know it is skewed towards the other side of it, towards the positive side of it, which means there are a lot of values, which a lot of houses whose actually price is more than 1 CR, right? So that is where it is making skewed towards a rise. So in case of when it is not skewed, you will have your mean, you will have your mode, you will have your median, all sharing the same point. Okay, so mean, median, and mode, they will all share the same point. So yeah, in this case, as I said, Kripa, that it's a ID column. So ID column will not matter much, right? So an ID column is just an unique number, and having it as a skewed or not skewed will not. Had it been in some other column which had made sense, definitely we could have deep dive on that. Okay, so that's basically what it allows you to see. Okay, let's try to see a few more things of what this report has brought. Okay, so now, okay, so we have for each of the variables. Okay, so let's say we want to check for state. Okay, so state top 10. Okay, so we have got the different states. Okay, and we have got the percentile. Isn't it cool, right? So you don't need to actually do all kind of these coding, right? And in just one line of code you get all kind of information. Okay, so I can go on. Let's say, let's try to check about fine. Okay, so fine, if we see kind of an histogram here, so we see that fine the count is 30, the 75, right? So this, what it does mean, that in this, most of the fine, when we went ahead and when we saw the the summary, right? Let's go there. So fine, we had a mean of 46, and my median was around 36, right? So we see the majority of the values lie in here. Okay, so for 36 we have got majority of the values, and then we have something. So this, for example, okay, this has an has, so we can obviously convert into numerical and have it more better. So it's basically trying to since it's a categorical bar right now, so it's trying to have a mode kind of picture. But if we see it in that way also, so we see that there is a huge proportion of people who are paying, which is a fine of 36, right? So majority of them are paying this. So if you see in terms of the maximum one, 301, there are only 6 people who are paying the fine. Now when we said that fine had outliers, we know, okay, so these are the folds, the 6 folds, which is basically increasing my mean value, right? This is where you need to tie the points. So if you see, my mean is 46 and my median is how much? 36, right? Why it is getting increased so much? It is getting increased so much because of the presence of these outliers, these 6 guys in here, right? Which is basically increasing your mean value, right? Once you kind of remove them, your mean value might reduce to the value of 36. Okay, so that's how you can basically select any of the variables, and that's where what I refer as interactive, right? So this can be as interactive as possible, and we can basically see, right? So for example, let's try to see which are the people where most of the what was the which was the maximum issuing agency. So it's basically PPA, right? Followed by police, followed by center C, followed by SEPTA, right? So again, it makes our life very easier. So it's kind of an interactive way to check all the variables. What is so this itself is kind of an univariate statistics. We can also see the interactions in this, right? So if you want, so let's say if I want to check fine, yeah, with, let's say I have we do not, let's use a zip code. Okay, and let's see if there is any kind of correlation with the zip code and fine. Okay, so if you see in here, so my all of the people who have been fined, right, more than 300, they have been all fined in this particular zip code. Okay, between 19100 and 1110. So we know that, okay, from where are these high uh, you know uh, uh, these high penalties coming, right? So these are mostly from there. So we now know exactly these are definitely outliers. So we see that mostly in there we have got a majority of the proportion coming from these guys, but we have these guys which are separate, and they all come in this within this particular zip code, right? So this again allows us to check different kind of uh, obviously it's all based on the my numeric variables only because it's in scatter plot, right? But this report also allows us to do any kind of interactions. Other thing that we want to check is obviously correlations, right? Correlations is something which we always want to check. So this is again a very important part of an EDA in terms of whenever we want to do any kind of analysis, be it in R, be it in Python, be it in Tableau, Power BI, we always are eager to see correlations between the variables. And one of the important way to see it is using the heat map. So basically, how do we read it? It's between correlation always ranges from -1 to 1, right? And obviously, every variable will be correlated with itself, right? And hence, we just have this upper frame. So we know that, for example, in these guys, so these guys division does not have any values and NaN, right? So here we know if it's a negative correlation or an positive correlation, right? So we also can switch between Spearman, Pearson, and Kendall Town. So the three different correlation stats that we measures that we have, and it allows us to check that also. Okay, missing value, something which we have checked, but we know from here, for example, division, right? It's such a beautiful way to represent it, right? This compared it to this, okay, when we were seeing the missing values initially, right? So something like this versus this, okay. So this gives us a very clear picture about how my missing values is, okay. So we can use different kind of charts like spectrum, heat map, dendrogram might not be the best one, but it shows like division has got my highest number of missing values. So I can play around with all of these charts and basically and have this interactive report, which uh, is again, what was the how many lines of code did I write to have all of this? Just one, right? Just one. And I got an access to all kind of information that my data has, right? So starting from number of missing values, a percentage of that, what is the basic insights about the variables in terms of skewness and not, and univariate statistics, right? I can also see the interactions like in terms of scatter plot, correlations between the variables, and also missing values, right? So this is something which is a very handy report, and again at the just using a one single line of code. Okay, I hope this looks uh, useful for you guys. Any questions before I move to the another package? So this is another, I would say this is like the first one, and this is among the other two packages which I will show. This is the most I would say gives you the most features, okay, in terms of doing any kind of preliminary analysis. So instead of writing separate codes, so let's say if I want to see the interactions between the variables, instead of writing separate codes for visualization, I can just have this as a drop down and find the interactions, right? Or if I want to just study a particular variable, like for example in this case I want to study fine, okay, or like the string agency, I can just go and see the what's the distribution like, what is the missing and all of that, right? And I can also have the mean, I can have the standard deviation, I can have the pie chart, word cloud if it's not applicable, right? And all of that, right? So this is this itself, it's a lot of information, right? And again, as I said, with just one line of code. Okay, I hope you found this interesting. Can we have QQ plots as a part of this, Kripa? So as a part of this, we generally have your box plots and your histograms. Okay. QQ plots are generally used for when we are trying to measure a particular distribution of a particular variable with a normal distribution. Okay. So then that's where QQ plots are very useful. But generally, like 99% of the cases, we will never see a normal distribution. Normal distribution is very ideal distribution. Okay. And this is hence it is mostly used in terms of regression when we try to say that or validate the assumption that errors are normally distributed or not, right? So by default, QQ plot is not a very useful plot from an EDA perspective, right? So we are not really finalizing anything based on the normal distribution of our variables. Okay, so hence that's where we have not included this, or the package has not included this. Okay. uh, any other questions, guys? I hope you were able to consume all of these features that we have as a part of this data prep, and also try to relate it with what when I meant of trying to not just report the variables or the numbers itself, but trying to tell something. For example, the one which we saw through the interactions using the relationship between fine and zip code, right? So this is the kind of insights which you need to find out, which you need to distill out and then present it to you, to either the client or your let's say your team. Okay, so this is the kind of insights which you should always focus upon. Okay, now let me just we have kind of 5 more minutes. I wanted to also show you the other two uh, packages which we have. So another one is basically profile report. Okay, so profile report DF, this is just the title which I have given. I've just given the title as EDA report. So profile report comes from the second package or the second custom library I must mention, which is profile report itself. And again, this is another one which is also very useful, which you can also use. This is basically the second option in terms of generating interactive visuals instead of writing a lot of codes. Okay, so since the entire objective of this session is to basically have something which is very less code intensive, but at the same time allows you to have a lot of information, a lot of visuals, so that you can derive insights from. Okay, let me go to your questions. Apart from let me read Tanuka's questions. Apart from what will be the conclusion from this EDA? Okay, so from this EDA, given that the number of data sets that we have, okay, the first conclusion that we have is definitely we do not have division variable. Okay, so for this, the entire column is missing. So definitely, if I want to use, if I cannot use this variable because I cannot impute all missing values, right? So one takeaway from this EDA is that division column is redundant. Okay, second is that in terms of missing values to continue with, we can zip code 32 are missing. And if I go in terms of the percentages and let's use zip code. Okay, then I know what is the percentage of variables. So I can basically, even though I cannot impute, because zip code is something which is very, very specific. It is like a name of a person. But still, I can say that since the zip codes are generally ranging from a certain number, which is 19102 to 19151, I can, and which is a good percentage, right? Out of 201, around 16% is missing. So definitely I need to impute the missing values. I can use an KNN for this. So that's the second takeaway of this EDA. The third takeaway would be in terms of interactions, which I said. So something like the presence of outliers, right? So that's a third takeaway. It's like in fine, we know that there are certain outliers which are present, which are these 6 outlier values, right? So I need to have a story around it of why we need to include or why we not need, why we not need to include. So for that, I can obviously go to my interactions, and as I said, I can check that okay, with what is the important thing. So what is that these 6 uh, the the people who have paid very high fine and they belong to the same group, right? So is it something related to this, and should we include this or not, right? Second, in terms of, just for fine, if I go, so if we kind of, if we remove the outliers, then I would say this particular variable fine, which is which is the most important variable from a parking violation point of view. So this looks pretty consistent, because uh, here we see that apart from this outliers, we do not have any major problems with this data, right? So that's one thing. We can also have try to build some kind of interactions with the latitude and longitude, or which effectively is the zip code. So kind of, having some kind of insights on the geography, like which is a geography which is playing the most, and that for that we can have and information about state, right? So we know that which states are there. So insights about, okay, so PA or New Jersey and all of this, New York. So we know that, okay, this is about from 201. Most of these violations are coming from the from this particular state, right? Followed by NJ, followed by NY, and so on and so forth. So these are like the takeaways that you should go on in terms of building around and stretching your story around. Imputing, Madhvi, imputing means replacing. Okay, if something is not available, I am basically predicting. I am basically using a proxy variable. Okay, so for example, let's say there are missing values which is not there, right? We are basically trying to predict or impute that particular value. Okay, so basically using a proxy measure. So that's what imputing means. Okay. Now let's also quickly see for the another one, which is a profile report. So here also we have something like overview, which is similar, and this has a little bit of lower functionality, but here also I have got things like variables. I have got, I have these variables, and I can have the details around it. I can also have the interactions, right? Instead of this, I can select these guys. Okay, so this is a different way of selecting. I can also have the correlations, right? Pearson, Spearman, Kendall's, and there's another one which is Feek, right? And again, missing values, right? So here also we have got heat map, dendrogram, matrix, right? So all kind of so it's like beautiful way of presenting missing values, right? So we generally know, okay, missing values, we know that's how. So if you want to give a description, give this data description to the client, so I can use this something like a matrix or of something like an heat map to tell that, okay, so we have got a lot of missing values, right? So again, this is quite useful. So we know if you want to have a sample of the data set, let's say if it was a really big data set, I can have a sample of roast. Okay, so to know, just to see like how my data looks like. Okay, so that's basically the another one, which is profile report. And the third one is AutoViz. Okay, so this is basically part of your Sweetviz class library. So here again, we use this AV class, which is part of the AutoViz class library or module, and use this again to generate interactive visuals. So again, by the time it generates, so basically, just to summarize, we discussed today like what is EDA, okay, why it is so important uh, in the role of a data science project, because it basically sets in premise in terms of data handling, data insights, data storytelling, and basically stretching towards model building, right? We also talked about few of the aspects about, like the basic codes, for example, like describe or is null.sum, right, which are like the basic codes. But then we went on to the interactive visuals, like using the create report part of data prep package, which gives us a lot of functionalities in terms of different kind of seeing the data from different angles, right? This another one is basically which we used was profile report. right? It's part of Pandas profiling, similar one, but I would say it's less fancier than your data prep report. And the third one, if it has come up, is your AutoViz. So AutoViz basically generates mostly your scatter plots and also gives information, right? So these are like the different scatter plots that we have, and it will give you all kind of information about what are the predictors, how many columns there are, number of string Boolean columns, number of district columns, number of NLP string columns, and so on and so forth. And it will try to then generate pair-wise correlations. Okay, so this is not interactive, by the way, guys. This is more of a static report that I generated through this. So if you want to generate more interactive reports about EDA, we can definitely use the first two ones. And I would say the preferred one, which is the data prep report. I hope you guys were able to follow through on this. And, uh, it was something new to learn. Was it for most of you? I hope. Were you able to follow through, everyone? So I will ensure that this notebook reaches to you guys, right? And you guys can really play around with, and obviously use a different data set to get the most out of it, and maybe publish it in your GitHub account or in your Kaggle repositories, and yeah, make and the most important thing is not doing a lot of coding and just using the one line of codes of these codes and generating a lot of visual statistics, and obviously having and trying to stitch a story around it, because as you are switching from writing a lot of codes, and then you just focus more on the coding rather than on switching the stories. But here you will have in a kind of an interactive way, and you can really focus on also on the story building part of the ED exercise. Okay, cool. So I hope this short session was helpful, and I see that yes, you guys liked it. So do follow us in the social media channels, including YouTube, LinkedIn, Instagram, and Telegram. So and also let us know if you have any questions. Okay, and I'm looking forward to having more sessions like this with you guys. Okay. And if you have any questions, do reach out to me on urpendu.ganguly. I think I never introduced myself. So my name is Urpendu, and I am kind of associated with Ivy for the past 5 years almost, and and so sorry, I need to type it for to everyone. So, and yeah, apart from that, I'm working as a data scientist, part of Accenture AI, right? So that's who I am, and happy to connect. Yeah, so that's my email ID, and feel free to connect. Okay, yeah, Kripa, I am. Cool. So you will get the data set, you will get these notebooks, do play with it, do try to, have your own visualizations, have your own story with your own data set, and let us know if of any question. Okay. So have a good weekend, guys. Have a good Friday evening. And yeah, definitely, definitely. And I will definitely see you guys again with a different short workshop. Okay, thank you guys, take care, and I will see you guys again. Okay, bye bye.